Great. So, afternoon, everyone. Thanks for coming along. It's great to be with you. This is our topic. We're going to talk about perfection, whether we can get there for speech recognition. By way of introduction, my name's Will Williams. I'm a machine learning engineer at Speechmatics. Speechmatics is a company that does speech recognition, kind of just really focus on one thing, do it well. We want to do speech to text as well as we can. I've been at Speechmatics for 5 years now. I was one of the first few people there, so I've been working on kind of pretty much every part of the tech stack that we have. And Hugh.
I'm Hewson Maxwell. I'm the emerging technology lead for Redby Media, working on access services. Redby Media is a media services company that does a large variety of media services for broadcasters, and I'm focused on the access services area. I lead a team which is responsible for bringing in automatic speech recognition and other machine learning technologies into our current workflows and future products. So Redby Media is responsible for producing about 200,000 hours of subtitling or captioning a year. Now, to begin with, I should probably be clear what we mean by subtitling or captioning, and forgive me for using them a little bit interchangeably. We're talking about subtitles for the deaf and hard of hearing. It's the same language. It's to make the media accessible. It's not about making it available to people who speak other languages. So we're not going to talk about machine translation here. We're going to talk about automatic speech recognition. We have a lot of people come up to us at trade shows for years now and say, oh, my phone understands me perfectly well. How come I still have to pay you guys to make subtitles? It's not that simple. If you really look at what's coming out in your phone, yes, one time in two it might be perfect, but the other time you get something that's utterly ridiculous. The ASR we've seen, it has improved massively over recent years, but it is still some way off where we'd need it to be. So what do we mean by perfection when we talk about broadcast subtitles? Well, that depends a little bit on what type of subtitling we're talking about. For offline subtitling, where it is you have the file ahead of time, you have time to work on the file, the expectation in regulated markets, in North America and Europe, is pretty much 100% accuracy. That is what the audience expect, and that is what the broadcasters expect. For live programming, where there isn't that time to work on improving it until it is perfect, or perfect for that context, the expectation is more like 98, 99% accuracy. Now, there are very few ASR providers who will claim that they can give you that level of accuracy, and the ones who do claim that, by all means evaluate them. You'll find they are not being fully honest. So we have workflows built on the back of ASR. We know it's an extremely useful technology. It's key to bringing down the price of captioning and bringing volumes up, which makes media more accessible for more people, and that's a good thing. But we need to have a layer of skilled subtitlers involved where we want to get to that sort of perfect level of subtitling. So where it is offline subtitling, generally we will start with an ASR transcript for a large range of our media, although not all, because correcting a transcript takes time. Even if the result doesn't seem that bad, correction takes time, whereas producing text from scratch is a little bit less time consuming. For live, we have two main workflows. One, which we call respeaking, where effectively a human repeats everything they hear on the screen, but they repeat it in a very level voice. They speak the punctuation, so they say comma, question mark, full stop. They are in a soundproof isolated booth, and that way you can push the accuracy of ASR up to 98, 99%. Another product which we've launched here using the ASR of Speechmatics at this show is fully automated captioning. Now, in the best circumstance, that'll get you to about 95%, which is genuinely useful for accessibility purposes, but is not what is expected yet on regulated markets. So today we're going to talk about a few of the issues we find, a few of the weaker areas with automatic speech recognition, and Will is going to cheer me up by telling me that they are soon to be solved. So one of the main issues we find is where we're dealing with uncommon, rare vocabulary, very specific genre areas, things like a farming show or a hobby show where they're talking about a new computer game and all the character names there. It's very hard to train an engine to expect all of this stuff. And what's more, even the news, every day there's a new range of vocabulary appearing there, like Novichok or whatever it may be tomorrow. So we have a number of strategies to try and deal with that. One thing we do a lot is we use house styles, which is where we see things that come incorrectly out of the automatic speech recognition, and we substitute them. And of course, we can apply that on a per genre, per program, per whatever basis, and that way you're only substituting where it's appropriate. Another approach is to train genre-specific ASR engines, but what we've generally found is that doesn't give the best results. While it might get the genre-specific vocabulary right more often, it won't get the general grammar right more often, and overall the accuracy goes down. And finally, the ASR providers often give us the chance to feed in vocabulary at real time, and that, again, pushes up the accuracy on those specific bits of terminology, but it also tends to slightly obsess the ASR engines, and they start hearing these words everywhere. So here's some examples where we were trying to feed in a lot of cooking vocabulary for all the multitude of cooking shows that there are these days. But we started getting things like where it heard can't roll it as quant row it, or let us pray before we eat as let us pray before we eat. So, Will, please tell me this will be fixed soon.
I certainly hope so. First thing to say about how we can have a go at dealing with these problems is that dealing with unknown vocabulary is actually quite a challenge for humans. If you heard the word, or maybe you saw Novichok written down for the first time, maybe you don't know how to say it, or the inverse problem, maybe you heard it, but you don't know how to spell it. These are the kind of problems that we have to get the machines to also solve. So the good news on that front is the models that we have can make a decent guess on how you split up words, how you model them. So that kind of part of the problem, we're in a good place. We have something called an acoustic model in speech recognition, which maps like slices of audio to parts of words, like but or for, and they're actually pretty good. So if you've got your words split up into the right subparts, you can probably do a good job of predicting like which phonemes are appearing at a given time. The thing which I guess Hugh alluded to, which is broken, or this is my hunch that the thing that's really broken, is that if you just add the word Novichok into a speech recognition system, you don't really know how that word gets used in English typically. So this is a problem of context, and we're not doing too well with it. So there's a couple of sort of directions that you can go in to deal with this. One thing is, you can make some modeling assumptions. So you could say, okay, I'm going to take my word, and every time I encounter words in my speech system, I'm going to treat them as just subwords. So maybe you had the word Novichoking, and you might split that up to Novichok and ing. And because you know from the rest of English how ing words kind of work, maybe you can then start using the word Novichoking correctly, if you see what I mean. So if you make the right modeling assumptions, you can start bringing in knowledge from the rest of your language to deal with this kind of issue. In the long run, we want more data to be able to deal with this properly. A bit like a human needs more data to know how to use new words, I guess. So if we did have more data about your kind of cooking vocab, hopefully we'll be doing a better job on it. I suppose lots of the issues that were in the last slide is going to be a tuning effort to try and get the system working well as you're adding more and more vocab to it.
Is there a limit to current modeling and current compute? If we had theoretically near infinite data, do you think we could model that full vocabulary, or would we hit a limit in terms of what we can actually model now because of the compute limits?
So I'd say like compute is limiting us to a certain degree. So I mean, if we did have all the data that used those words in exactly all the right context, then in reality we'd probably actually be able to do a pretty good job on them, but not necessarily a perfect job.
Okay. So another weakness for us in ASR is punctuation. A lot of ASR engines will just give you a list of words with no punctuation or capitalization, or they'll give you some punctuation, but it's very sparse, or they'll go to the other extreme and start wildly punctuating every few words. And for fully automated workflows, this is extremely challenging to deal with because it's very hard to structure the subtitles. It's very hard to structure them in a way that they're readable. It's very hard to know where to make separations. And you end up with subtitles that are just really difficult to use. And for the workflows where we're actually performing QC layers, it still is a big hit on efficiency and therefore cost because, again, it's very hard to segment them. And as you go to correct them, you end up having to do a lot of merging, a lot of fixing, a lot of retiming, a lot of reseparating. It becomes very, very time consuming. And we have seen some improvements in recent years there in punctuation, but it's felt a bit like a second-class citizen. It's not been a priority, so I feel like you were going to tell me some good news now.
So I can be a little bit more positive on this one, I think. So I'm going to start by saying the same thing I think I said last time, which is this is kind of a hard problem from one point of view, which is evaluation, where you could end up with two transcripts punctuated in slightly different ways, but actually they're both the perfect transcript, if you see what I mean.
I have to point out, our subtitlers would definitely not agree with that statement, but I do think it's true.
Yeah, so that's actually, it's quite useful. So if the assumptions of all your sort of subtitlers were encoded in a data set in a very consistent way, then there's absolutely no reason we couldn't learn how to punctuate in that way. And this is really good news, because it means we can have data sets that have these very specific punctuation rules encoded in them, and we can just use machine learning to learn that mapping. And it's not actually a very difficult mapping compared to the whole ASR problem, which is actually a reasonably tricky problem. I think punctuation is pretty easy, and there's no real reason why it hasn't been a solved problem. I don't see why. So yeah, as you were saying before, punctuation, it has been a second-class citizen, and there's sat like as a post-processing step right on the end of the pipeline. We've never really done a massively good job of it. I should mention that there are a couple of issues for things like that aren't English. So maybe in French, if you say a statement and you sort of inflect upwards at the end, it could turn it into a question. So it's not just a purely sort of text-to-text thing. You might need to do some modeling on the audio to figure out exactly what's going on. So it's not necessarily easy. I think it's reasonably easy in English, actually. But this is the point I want to make, is that we actually have everything at our disposal to build punctuation models that work. There's no real reason why we shouldn't have them right now. It's just an engineering effort. And actually, this is a subject of my research right now at the moment. So I'm working on building punctuation models. And the sort of initial results are looking interesting. I thought I'd share with you something that came out last week, actually, so hot off the press. OK, so the top is the reference. This is the ground truth. This is how the punctuation should happen, according to our data sources, I suppose. The middle is what, if you uploaded to Speechmatics, that's what you get. So we have got a sort of slightly half-hearted post-processing step done there. And we've now trained some models recently which are like explicitly attacking this punctuation problem, which includes like adding full stops in, adding commas, and maybe a couple of other things. And you can see it's doing a better job. And you don't have to do too much to produce some convincing output that punctuation that makes it look decent enough that maybe he would be happy.
Yep, we want it soon, please. OK, the last one we're going to talk about is specific dialects. So as an Irishman whose phone has only started to understand him in the last kind of year or so, I know all too well that automatic speech recognition does not work with less common dialects. And the days of broadcasters preferring to focus on one major dominant dialect are long gone. These days, broadcasters want to give a full range of dialectic diversity, and I think that's a great thing. I mean, it results in things like people needing subtitles for the wire, but isn't it great to see all of that? As subtitles producers, it's painful to deal with. ASR generally either gives you a global model or a model that broke it into, say, American English, British English, or Latin American Spanish, Iberian Spanish. But when they say these things, it doesn't really cover the dialectical variety of those regions. It covers the mainstream middle-class dialect of that area, or a few of them. Now, the global models we've seen are genuinely useful in the sense we often have a lot of broadcast TV that has a panel show where there's an Australian and a British person and an American on the audience, and now that'll go through fine. And even where we just aren't that sure what sort of dialects are going to be in there, it saves us having to make a choice at the start, and that saves time. But if there's shows we know that are very heavy on regional accents, there's just no point in us using ASR at this stage. So give me hope.
I'll do my best. So for me, the whole issue of like accents is really one of the defining issues of ASR. So I'm reliably informed that in the late 80s, speech recognition was a solved issue with just one speaker. You know, if you had all the data you need on that one speaker, you could do a really good job of it. And kind of in line with machine learning, actually, one of the big goals is to generalize better and better and better from your data. So eventually, we'll incorporate all types of speaker, all accents. I want to be slightly cheeky at this point and say that if you got more data, if we had more data, it would solve 80% of this problem. So if you just dropped on my desk all the data that we have for, say, the equivalent of a Fox News speaker, we have loads of this kind of media broadcast, like professional stuff. If you suddenly dropped on my desk like the same amount of like Glaswegian speaking in the pub, and maybe Hugh speaking in the pub as well, you dropped on my desk, so we'll be able to build models which would do a really good job of it. But getting hold of that data, as you can imagine, is really difficult. So that is one of the issues in this area, is that data is not going to be appearing on my desk soon. Like, even with a concerted effort to get hold of it, it's still going to be very difficult. So I suppose there are a couple of things that we can do as a speech recognition company to try and get hold of that data. We can see what people are uploading to speechmatics.com. Maybe if we're doing a poor job on it, we can get it professionally transcribed, close that data loop, and iteratively move towards a solution that can start dealing with what we're actually seeing, arrive at speechmatics.com. So in the long term, we're going to get there, but it'd be nice if someone did roll up to my desk and just dump everything there. But we know that's not going to happen. Yeah, so thinking about this kind of long-term approach, and you mentioned about generic models. Do you have generic models or specific models? We really feel that in the long term, generic models are the way to go. So why is that? We know that the human brain can do it. We know that that we can deal with multiple accents, maybe even multiple languages. So from a modeling point of view, we know there are solutions out there that can do it. So in the limit, as we get more and more data and our models get bigger, we know that we're going to end up with really good sort of one-size-fits-all models. And those things are going to be able to share perhaps learnings across different accents. So maybe if I start doing really well on Hugh's accent, it's going to do well on maybe some of your accents in this room. So that's the ideal, is you can sort of leverage progress on one accent and another accent. The other thing that I think is the biggest one for me as an engineer is we want to reduce operational complexity. Just brilliant if that scenario did happen where suddenly loads of data was dropped onto my desk, I can push it all into this one giant model, roll that out, and then everybody who's using that model for their particular accents is going to get the benefits immediately. There's only one model to deal with. You know, we're only versioning one model. You don't have to choose. This particular kind of accent is a real pain. So we'd love to get away from kind of these really, really custom solutions and go for the sort of one model to rule them all sort of approach.
Is there a limit to how many dialects we can put in one model currently if we had the data?
Yeah, so in the real world, things aren't quite as rosy, and we do have computational budgets, which means we kind of need to decide how much of one accent to use to train the model. So in reality, you're probably only going to be able to push maybe 4 or 5 different accents into models that I would say are performant enough to be actually put out into the real world. But yeah, theoretically, given sort of sufficient capacity, as the model sizes get bigger and bigger, we can push more and more accents into them. So so that's quite a nice, I guess, nice future for this, is that as our models do get bigger, we can be increasingly putting more and more accents into them.
So I guess I'd ask you the question, do you believe perfection is possible with automatic speech recognition?
So I want to throw that one out to the audience. Who thinks that perfection is possible? Okay, some optimism on the front row. I presume the rest of you think no. And I'm going to give a sort of a yes and no answer to this before wrapping up. So I'd say no. Perfection is going to be impossible because language is constantly evolving. New slang is always going to be appearing and being used, and we don't know how it's spelt. We don't know how to deal with it. Second, people really do mumble, and sometimes there isn't enough signal in the data to be able to discern the correct words. The other thing is that humans rely often on context to know which the correct word actually was that was spoken. So if I'm making a pun or I'm talking about some kind of in-joke, I'm only the one that really knows how that word is spelt. An ASR system has got no idea about the context of my life and the real world, so it can never know 100% the right word. So So that kind of like perfection and objective perfection perhaps is going to be a really difficult ideal to hit. But I think, yes, we can achieve perfection in a more realistic kind of 98, 99% accuracy sort of sense. So maybe we just output nothing when there's not enough signal in the data, and that's good enough. That's the right thing to do. Maybe you could say that. The other thing is the data sets that we have are slowly converging to the kind of data sets that our human brains have been exposed to since we were children, which is massive. So as they do so, we know that our models are going to get better and better. And I always like to throw something slightly controversial in. So I would hazard that if you put a pause button on the tech and the algorithms that we have today, and you simply just waited 10 years, and you got the compute from in 10 years' time, and the amount of data that we have in 10 years' time, you retrained the systems, I bet we'd be at your 98, 99% accuracy. So I think we're on a really nice trajectory to get close to that ideal of perfection. So with that, I'll finish up. Do come and visit us. One thing to mention is we're going to have a webinar in October that dives more into these sorts of topics. We haven't said everything that we could say, so we're going to have one of those where we're going to dive more into the details of these things. If you'd like to join us, we'd love to have you on that. Details will be appearing on speechmatics.com soon.
And if you would like to see the fully automated live solution that we're running using Speechmatics speech recognition, you can see it at Hall 5 at the Red Bee stand. Thank you.
Thank you very much.